Hey class, in today's lesson we're going to talk about solving trigonometric equations, which is found in section 5.3 part 3. Our objective is to solve trigonometric equations involving multiple angles and inverse functions. So in example 8, functions on multiple angles, we would need to find all the solutions of the equation. So as we've done before, what we want to do is essentially solve for solve for our unknown variable, which is t. So we're going to add 1 to both sides. So we're left with 2 cosine of 3t equal to 1. If we divide both sides by 2, we get cosine of 3t equal to 1/2. Okay, as we've done before, essentially what you would have is, if this had been cosine of t of 1/2, we know that we would be talking about a 60-degree angle, right? So let's talk about that first. Where's cosine positive? Well, cosine is positive in the first and the fourth quadrant, okay? And if I think about cosine as being adjacent over hypotenuse, the adjacent is 1, the hypotenuse is 2, so then that means that this is a 60-degree angle. So a 60-degree angle in quadrant 1 would be 60 degrees, and a 60-degree angle in quadrant 4 would be 300 degrees. However, that's only the case if we were talking about cosine of t equals 1/2. In this case, we have cosine of 3t equal to 1/2. So because of the 3t, essentially what you have to do is you have to set your 3t equal to 60 and your 3t equal to 300 degrees. Or in other words, just take whatever angles that you find and divide them by 3. So if I take 60 and divide it by 3, that's going to give me t equals to 20 degrees and t equals 100 degrees. Now, as far as radians go, I'm going to use a different color. A 60-degree angle in quadrant 1 would be considered pi over 3. But in quadrant 4, that would be considered 5 pi over 3. So to divide those fractions by 3, essentially all you're doing is multiplying times 1/3. So in other words, pi over 3 times 1/3 would make that pi over 9. So 20 degrees is the same thing as pi over 9. And the 5 pi over 3, again, if I multiply that times 1/3, that would give me 5 pi over 9, which is the same thing as 100 degrees. I don't know why oh yeah, there we go, 5 pi over 9. Okay, so those are your solutions for our first equation. Let's look at the next one. All right, so again, we need to find all the solutions. So if we have 3 times the tangent of x over 2 plus 3, again, you want to solve for x. So if we subtract 3, we have 3 tan x, or 3 tangent of x over 2, equal to -3. From there, I want to divide by 3 so I can get just a single tangent. So I have tangent of x over 2 equal to -1. Well, let's think about in general where tangent is -1. Tangent would be -1, or even +1 for that matter, at your pi over 4s, right? But let's think about our quadrants. So if I say all students take calculus, tangent is negative in my second and in my fourth quadrant. So in second quadrant, when I think about degrees, this is going to be considered 135 degrees. And when I think about in quadrant 4, a 45-degree angle will be 315 degrees. However, the issue is that this is not a regular tangent function. It's a tan x over 2 function. So essentially I have to take that x over 2 and set that equal to 135 degrees. What that means then is that I would have to multiply both sides by 2. And so x is going to equal 270 degrees for the first one. And if I do the same thing with x over 2 equal to 315, again, if I multiplied it by 2, I would get x equals 630, but the deal is I don't have to worry about the second solution because it's too big. It's outside of a full unit circle. So x equals 270, or in radians, we know 270 degrees is the same thing as 3 pi over 2. So that is our only solution for this problem. Let's look at our last problem. That in the first, oh my goodness. So again, we need to find the solutions. Again, we have the issue of we have more than one trig function. So we want to get them all in terms of one trig function. You should recognize secant and tangent, that there is a relationship. I want to change that secant squared though in terms of tangent. And so secant squared x in terms of tangent is plus tangent squared. That's a Pythagorean identity. Also, I want to subtract 4. I should have done that in the first one. So minus 4 on both sides. So that'll give me, if I put it in order now, that'll give me tangent squared x minus 2 tangent x. And then 1 minus 4 is negative 3. Okay, if I substitute and say that for every 10x, it's actually an x, that would give me x squared minus 2x, that's a 10x, sorry, and then minus 3. AC would say that it's negative 3, and so I have x minus 3 and x plus 1, because negative 3 and positive 1 would give me negative 2. Okay, if I trade them back out for tangent functions, we would have that tan x minus 3 equals 0. And I also have tan x plus 1 equal to 0. Okay, over here, if I add 3 to both sides, I would have that tan x equals 3. The deal is since the range is infinite, that's actually something that we could find. But to be able to find the actual angle that refers to, we would have to do the arctan, or the inverse of tan to be able to find the angle. So x would be the inverse of tan of 3. So let me figure out what that is. Okay, so if we had it in degrees, that would be about 71.6 degrees. Let's just say it's about 71.6 degrees. So that's the first solution. And then for this second solution, I would subtract 1. And so this is saying, well, where is tan x equal to negative 1? Again, we've already discussed that when tangent is a 1, we're talking about a 45-degree angle. And specifically, tangent is only negative in the second and fourth quadrants. So those 45-degree angles that happen in the second and fourth quadrants as degrees, since the other problem was in degrees, I'll say that they are equal to 135 degrees and 315 degrees. And those are our answers. If you have any questions about these sections, again, please be sure to come see me for tutoring.